In this video, I'm going to talk a little bit about domain and range. It's a really hard concept for students, and hopefully we'll get through some of it, or at least get you to some sort of understanding. Remember I said that domain refers to the x values for which a graph exists. So I'm going to start with something that's actually really simple to find the domain and range of. So remember that the x-axis is this axis here. The domain is for what x values this graph exists. Well, it exists for every x value between these two. Well, what are those two? This is -3 and this is +3. Because at x is 4, I can't go up or down to get to the circle, but if I'm at x is 1, I can go up and get to the circle here, I can go down and get to the circle here. That means for what it exists. It exists here and here. It does not exist out here. So, let me erase that. We would say that the domain would be any x value between -3 and 3. This is a much easier way of writing the domain. It's called interval notation. The range are the y values. That's how high and low the graph goes. So the graph only goes up to here and down to here. Well, this is y is 3, and this is y is -3. So we would say the range is between -3 and 3. Well, now let's look at one where there isn't a distinct start and finish. Let's look at this parabola. This is an upside down parabola. And one of the things you have to remember is that these two pieces of the graph, they're going down forever. Even though there's no arrows there, I put them there. So here's the thing. How far does the graph go left and right? Well, although the graph is going down, it's going down and to the left forever. So if I wanted to extend this graph out, I could probably find where this graph has an x value of -5, because the graph is just going to keep getting wider and wider. And even though this is 10, and I can't see where x is 10 on this particular graph on this screen, I have to imagine this is going down and to the right forever. Well, it turns out that all parabolas have a domain of all real numbers. That means that every value of x that you plug into a quadratic equation will always give you an output. Here's what's not all real numbers: the range. The range are the y values. So this is y is -2. Well, I see where the graph has a y value of -2. Here's y is 1. I can see where the graph has a y value of 1. This is 6. I can see where the graph has a y value of 6. But how about at 7? I don't hit the graph at all. That's because the graph only exists when the y values are under 6. Under means less than or equal to. So we say that the range is y is less than or equal to 6. Because there are no y values bigger than 6 that will hit the green curve. Now this is all fine and dandy. Just a reminder, all parabolas, their domain is all real numbers. All linear equations, if a linear equation, remember, is a straight line. I don't know why that skipped. For linear equations, both the domain and the range are all real numbers. But now let's talk about reasonableness of domain. Let's say that this were the graph of me throwing a ball in the air. So I throw the ball in the air, and you know gravity is going to make it come back down, and eventually it's going to hit the ground. So this graph, instead of calling this the x-axis, we would call this time, or t. And the y-axis, instead of calling it y, we would call it h, for height above the ground. So it's actually a graph of how long the ball is in the air versus how high it goes. Here's where reasonableness comes in. The x-axis is the ground. That means that these two portions down here don't actually exist unless you have a ball that's so heavy that when it drops on the ground, it digs under the ground. But I'm sure that's not going to happen. So what's going to happen is I'm standing over here at the origin. I throw the ball in the air and then it hits a maximum height, it falls down, and then it hits the ground. So what's the reasonable domain? Well, the reasonable domain is from 0 to 2. The ball is only in the air for 2 seconds. The reason that that's our reasonable domain is because after 2 seconds, the ball is lying on the ground. So at 5 seconds, it's still lying on the ground. It doesn't actually continue going down into the ground towards the core of the earth. That wouldn't make any sense. And then the reasonable range would be between the ground, which is 0, a height of 0, all the way up to this, which is a height of 6. So when we're talking about application problems, real-world problems, the domain and range are not usually going to be all real numbers. And what is reasonable depends on the circumstances. This problem was about throwing a ball in the air, and then it comes back down and hits the ground. When we talk about money in corporations, it actually can happen that you can have negative money when you spend more than you actually have. And corporations do that all the time. So when you talk about money, the reasonableness of domain and range can be slightly different. So you have to think about the world around you and what you actually know. I'm sure you've all thrown a ball in the air at some point in time. Yes, maybe you were throwing it to someone, but you can imagine if you throw a ball in the air and it comes and hits the ground. That's it. Its motion is done. That's physics. So sometimes range and domain, when we're looking at just a general function, we're looking at how far a graph goes left and right and how far a graph goes up and down. But when we run across application problems, you have to ask yourself about reasonableness. You can have a graph that tells more than the story you want to tell it.